heavy-duty road transport. And just for your information, this is a picture from our project in Sweden. It's a 2-kilometer demonstration project on a public highway 2 hours north of Stockholm. And so it's already reality. But let's start at the beginning. So why does Siemens look into this field of technology? So there are a lot of studies which have more or less the same conclusion. Freight will increase over the next years. The World Business Council of Sustainable Development says freight transport in general will triple until 2050. And ITF says the surface freight density will increase. You can see it in this little animation here. So there's a huge challenge in the future in terms for climate change and global warming. And so somehow we need to reduce the greenhouse gas emissions to face climate change and global warming. And right now, the energy sector is the largest source of CO2 emissions, but they will decarbonize until 2050, so they're doing pretty good. But in 2050, without any change, the transport sector will be the largest source of CO2 emissions. And if we have a look into transport more in detail, most of the CO2 emissions come from surface freight. So somehow we need to find measures to reduce road freight CO2 emissions. And Mark already mentioned this ASI framework, avoid, shift, improve, and this applies here as well. Like we could try to avoid goods transport, but as we have seen on the first slide, this won't happen. Then we can shift freight to more efficient ways of modes of transport. But like for example rail, but this is somehow limited. Like for example in Germany, we have like 70% of the goods are transported on the road. So it's not possible to shift all to rail. And so the last part of this framework is improve. So we have to improve those modes of transport which are not efficient right now. And here we have an example from Germany as well. These are the CO2 emissions without any actions until 2050. And of course there are some small tools what we can do. We can do like some rail expansion, so we can lower it to 87. We can do logistic optimization. We can do some improved efficiency, of course, or some biodiesel blending. So now we are at 61 million tons, but the target level is 8 million tons. This is set by the German government. So there's a huge gap between the tools we already have or we see to the target level. So somehow we need some innovative solutions to close this gap. And that's why Siemens said, okay, hey, we have a great portfolio of solutions. Let's have a look into the concepts, how to make heavy-duty vehicles more climate friendly. And of course, the first chapter is onboard storage, so we can talk about alternative fuels like CNG or LNG, but here we still have a fossil source, and also here's methane involved. Methane is like 25 times more harmful to the climate than CO2, so that's not a good solution. Biofuels are limited somehow, so they are probably needed by other modes of transport like airplanes in the future, which are not so easy to decarbonize. And also the source of biofuels is mostly agriculture, which is not climate friendly as well. So what about electricity on board? What about batteries, capacitors? Here we have the problem with heavy-duty vehicles, the size of the battery. So we asked Scania, which is one of our truck OEM partners, what's the size of a battery for a 40-ton truck which would like to drive 1,000 kilometers? They told us it's like 30 tons. So we have 10 tons left for goods, more or less, and that's not the purpose of a truck in the end. Also, with batteries and capacitors, we have some life cycle issues. Right now, you have to change the battery after 4 or 5 years. It will getting better, but still, there will be a lot of batteries in the end, which have to put on the dump. So it's not really climate friendly as well. And even if you think about autonomous driving in the future, when trucks are running like 24/7, when do you charge the batteries, for example? What about fuel cells? It's quite a topic in Brussels right now. There's a lot of lobbyism for it, but the problem with fuel cell is you have like a multiple change of energy, so the efficiency is very low. On the next slide, I have a comparison of the efficiencies. You can see it, and so onboard storage for heavy-duty vehicles, we didn't find that a good solution. So what about external power supply? Here we could have like a contactless external power supply, for example, inductive power supply. The problem with inductive power supply is you have some side-to-side movements of the truck, and there's also some distance between the road surface where the device is and the device on the truck, so there will be a loss of efficiency. And it's quite a complex technology, which is as well quite expensive, so that is not a good solution. We also tried to get into linear synchronous motor concepts. It's like the transfer rapide or the maglev, but it's not suitable for heavy traffic situations. So we came to these conductive external power supply solutions, which already have like some kind of scientific term made up from a Swedish scientist called electric road systems. And here we have, for example, a ground-based contact line, which we know from trains, from Alstom, this APS system, where we have like segments under power where the train drives over it. And for trains, it's suitable, but like these segments are like 30 meters long or 40, and so the truck won't cover it all when it's under power. So there are of course some safety issues, and as well we are talking about something in the ground, like in the road surface. So, and we're talking about 40-ton trucks which are driving over it, and it's very sensitive to disruptions, this technology. So there will be a lot of maintenance issues in the end. So that's why Siemens came up with an overhead contact line, which we somehow invented 100 years ago for the rail electrification. Why shouldn't we start now with the road electrification? And this e-highway, it's called, system contains like a hybrid truck for these streets which are not electrified. But like for the long haul, we have like an overhead contact line system on the road. It's like for trains, and it's a very efficient system. You can see on the next slide where I've promised you the comparison between the well-to-wheel efficiencies, and that's what I mentioned in the panel already. It's very important to have to look at the well-to-wheel efficiency, like from the source of the energy here in an optimal case symbolized by and windmills, or it's renewable energy, but like to get all the energy from renewable sources, it's like another part of the story where the utilities have to deal with it. And like power to gas has like 20% of efficiency, hydrogen 29, batteries better 62, and these electric road systems I mentioned, these conductive external power supplies, they have like 77% of efficiency. So like for the users itself, for the forwarding agents, it's very cheap to use these electric road systems in the end. And I have to add, this figure is without recuperation. So the beauty of this electric road system is that you can use the braking energy to load the battery on board because it's hybrid track, or to put it back onto the grid as well. So if you consider recuperation as well, you have like an efficiency of 85%, which is tremendously high. And like all the solutions I mentioned need some kind of infrastructure. And we always get the question like, oh no, do we have to build these wires on every street, like in front of my house? No, absolutely not. Yeah, like this is an example from Germany as well. You have to analyze where's the most freight transport on the roads. And for example, in Germany, we have like 12,000 kilometers of highways, which already covers 60% of the HGV emissions. And like on the most intensely used 4,000 kilometers, you can cover 60% of all ton kilometers covered on the highway. So like with 4,000 kilometers out of 600,000 kilometers total road network, you're doing a major step towards more climate-friendly heavy-duty transport. And this approach can be applied everywhere in the world. Like it's the same for Korea, Japan. You just have to analyze where are the main road corridors or routes. And yeah, normally I show some animation. You can look it up on YouTube, but I've just cut out the important stuff. Like I mentioned, like the system it's a hybrid system. So you have like, for example, a combustion engine or a battery or a fuel cell. It doesn't matter. You have the electric motor, gearbox, cardan shaft, and like so for the driver itself, there's no change in the operation. You can drive it like a normal truck. You can drive with a combustion engine on the road where the wires are, and then we have like a laser sensor which detects there's a catenary above me, so the pantograph, the connecting device, is rising up and connects to the wires, and then we are running on pure electricity, and via the substations electricity gets into the wires. So even like overtaking is no problem. So the driver puts the indicator, is overtaking. In this moment, when he's like going out of the lane with the wires, the pantograph is going down. He's jumping, or like he's switching over to combustion engine or battery. He's overtaking. He's going back under the wires. Laser sensor detects, and you're going back up with the pantograph and running back on electricity. So, and also it's very easy to integrate in existing infrastructure, because the poles are like besides the road. So like most of the work is done besides the road. You do not have to close the road for construction or maintenance and so on. So as I mentioned, like it doesn't matter which kind of truck type you have. Like it's compatible with and complementary to other alternative fuel technology. So it doesn't matter if you have like a tractor truck with 3 axles, a rigid truck with 3 axles, or what kind of hybrid. If you have like a small battery or a medium engine which is running on diesel, biofuel, or CNG, it totally doesn't matter. So it's like some kind of backbone technology, and so we do not force any truck manufacturer to build specific trucks, or like forwarding agents to buy specific trucks for the system. You just need a hybrid truck, then you can equip it with an pantograph, with a connecting device, and then you are able to run on electricity on this e-highway. And where are we now, or why did we started? We started like 2010 with 3 research projects which were funded by the German Federal Ministry of Environment. We have like a test track north of Berlin in Germany with realistic highway conditions, where we like tested the technical feasibility of the system. And of course we had some assessment with universities and the German Federal Highway Research Institute to check, like, for example, safety issues and so on. And everything is fine. Like, there are no issues that, for example, the wires cover the signs. No worries. It's all fine. It works fine. There are no issues. And there are a lot of public reports which were not funded by Siemens that I have to mention, which conclude that this overhead catenary system is a very good solution to reach the climate goals of the European Union in 2050. And there's one study from the Umweltbundesamt, it's called in German. It's a German environmental agency. And they compared different solutions and looked on the economical side. So it's unfortunately the report is only in German, so I have to translate a little bit. Like, this is energy supply, whereas the e-highway or the overhead catenary system is much cheaper than like power to liquid solution, a methane solution, and a hydrogen solution, as well with the infrastructure, with the vehicle supply, and this is important. Like in total, an overhead catenary system is like half expensive as the next possible solution to reduce CO2 emissions to reach the climate goals in the end. And like right now, we have, like, as I mentioned in the beginning, we have one project in Sweden. The operation started last year, June. It's on a 2 kilometers highway, public highway. You can see it on the picture. And here our truck OEM partner is Scania. And then we have another project in the USA, in the port of Long Beach and in Los Angeles. Here we have Volvo as a truck partner, or Mack, the Volvo daughter of in the US. And as well, there are 2 field trials in Germany planned, in the northern part of Germany and in the middle part, and close to Frankfurt, which will start construction end of the year. So there will be this overhead catenary system will be in reality and will be tested under real conditions for further information and demonstration. And just to let you know where you can use this system, as I mentioned, like it's highly valuable for roads where there's a lot of transport, like for example shuttle transport in industry hubs or in ports, as well of course for mining. But of course, like long term, you have to electrify the long haul traffic to reduce CO2 emissions and reduce greenhouse gas emissions to face climate change in the end. And yes, that's the end of my presentation. Thank you very much.